Hey class, this is your guided notes, or at least the beginning of the guided notes for lesson 1.3. Excuse me, we're going to be describing location and a distribution. So we've kind of already done that a little with describing the 5-number summary, where your numbers are falling on a number line, but there are other ways we could do it. So there are 25 students in a math class. The teacher gave a test worth 50 points, and these are their scores. The underlined score here is Emily's, and I want to know how she performed relative to her classmates. So you could create a dot plot to answer this question, and then you'd see, oh, here's Emily's score. She did better than a lot of kids, but I would like to quantify that and be able to describe it in more precise terms. And one of the ways is with saying measures of location of percentiles. A percentile is the percent value of a distribution that are less than the individual's data value. Whoa, that was weird. What's going on? Sorry. Less than. So if somebody had a baby and they were told that their baby's weight was the 40th percentile, that means that 40% of other babies weigh less than that baby. You hear it a lot with, if you ever have a kid or hear about kids going to the doctor, they say it a lot for baby weights and heights. They also will use it for test scores. If you remember back when you used to get like PSAE or whatever the other tests were you took in grade school and stuff, they would give you percentiles a lot. One thing to note, percentiles are a location, not some range. So you're not going to say that an observation is in a percentile, it is at the percentile. You are the 40th percentile, not that you are within some part of the 40th percentile. You are that number that chops off 40% below you, so 60% above you. So I'd like the percentile for Emily's score. I want to know what percent of people had a score lower than Emily's. So you could go through and count every little dot. So there's 1 person, 2 person, 3 people, 4, 5. You can go through all of them that way. I also had told you that there are 25 students in this class. So Emily and everybody above would be 1, 2, 3, 4, 5 people. If there are 5 Emily and above, that means there would be 20 people, 20 dots that I'd be counting down here. I don't really want to count 20 out by myself, so I'm just going to go with the fact that I know that it would be 20 out of her class of 25. So if I want the percent that's below, I put the count number of people below out of the total number of 25. That gets me 80% or 0.8 is what would come out of your calculator. So I could say that her score is the 80th percentile, which is another way of just communicating that her score is better than 80% of other students. So then what is the percentile for Jacob, who scored an 18 on the test? Let's pretend it said scored 18 on the test. That would mean this one is Jacob. He only scored better than one other student. So his percentile would be found by that one person out of 25, because again, we're measuring the number of people, the percent of people who score lower than the individual. So we would say his score is the 4th percentile. And then Maria, her test is at the 48th percentile of the distribution. I want to interpret this value in context and figure out what score Maria earned. So again, percentiles are the percent of people who are below you. So in context, I would say that 48% of students in a class earned a lower score than Maria. To figure out how many that is, if 48% were lower, I need to know what is 48% of the total. What is 48% of 25? Which means I need to change that to a decimal. Of tells me to multiply. I'm going to take 0.48 times 25, which gets me 12. Now that 12 is not her score. This is how many students scored lower than Maria. So to find out that actual score, I'm just going to go up and count. I'm going to count 12 of these people so that I can say, okay, Maria must be the 13th if 12 is below. 12 are below. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12 were below Maria. That means one of these 38s would have been Maria. So her score would have been a 38 on that particular math test. We can also create a little distribution table like this where this is representing the ages of the first 45 U.S. presidents when they took office, so how old they were at that particular time. Sorry, I want to change colors. I have the frequency. There are 2 presidents of the first 45 that were in this age range of 40 to 44. There were 7, 45 to 49. This is just the count. I would like to change that into relative frequency, which means compared to the whole group. Rather than just a count of 2, I want to know 2 out of, and again, this is the first 45. So 2 out of 45 tells me what percent were in that group. If I put that in my calculator, it's approximately 4.4%. So I can do the same thing, 7 out of 45. I'm just going to keep taking the frequency and divide by the total. I'm going to finish that later. Because I also want to talk about how we can do something called cumulative frequency. Cumulative is a lot like your cumulative GPA. It's starting at one point and all the things before. So it's not just your senior year GPA, it's your senior year and your junior and your sophomore and your freshman. So for the cumulative frequency, it starts out with just a 2 because I'm just starting out. But then I have the 7 from this age range plus the 2 before it, which means this has a cumulative frequency of 9. And then I'm going to take the 13 from this age range plus the 7 plus the 2, and so on and so forth. It's just going to keep accumulating. It's going to keep going up as you go down the chart, so that by the time you're done and you've added all of them, if I add all 7 of these values here, then I end up getting 45. So I know my cumulative frequency ends at 45. I can also do cumulative relative frequency, which basically means take the cumulative frequency and convert it to relative frequency. So not just a 2 out of the total of 45, which we already knew was 4.4%. Not just the frequency of 45, the cumulative frequency of 45, not just the cumulative frequency of 9, but 9 out of 45. So you could keep dividing these values, but you might notice it's also the same thing as just summing these ones as you go down the chart. So 4.4 plus 15.6 gets me this 20. If I add on another 28.9, I'm going to get 48.9. And I'm just going to keep working down the chart. I'm going to finish this chart in a moment so we can use it on the next example, but I'm going to put that in another video so these don't end up ungodly huge file sizes to upload. So finish example 2 before you watch the next video. In the next video, we'll finish this last part and a little bit of the next page.